So this one is the power loss experiment setup. Knob of power setter, input, output, and whatever the output we can measure through this multimeter. Let's see, turn on this multimeter. Yeah, it is okay. Now we have a 5-meter cable of optical fiber cable, and this one is the 1-meter optical fiber cable, and we have one coupler. Use this coupler, we can connect both optical fiber cable. So put the title, power loss in optical fiber cable. We already aware with the optical fiber terminology. Objective to study the various type of losses in optical fiber and measure it. So first question is how or when the loss is occurs. So let's see, this one is a 1-meter cable, this one is the 5-meter cable. We have to connect both cable using this coupler, and due to this coupler is not a main part of optical fiber cable, so due to the coupler we have some losses. Another bending, which is another reason. Suppose this cable which is made from the one of the material X and this one is Y, so due to some different material, due to the different numerical aperture value, due to the connection glitch, we have a various type of losses in this optical fiber cable. So let's check the observation table. In the observation table there is so simple things, PO1 and PO2. PO1 which is indicate for 1 meter output power, and PO2 which is a 5 meter output power. And how to measure the loss, we have a simple terminology. Let's see, this one is a one cable. Suppose the output of this cable is 100, okay, and now after that I connect the second one, this red one, and the output of this red one is 95. Okay, so how much my loss? 100 minus 95, so the remaining value is only 5. So 5, which is loss of this particular connection. So same terminology we can apply on this experiment setup. Okay, let's turn on. You can see light is here. Put the first terminal of this optical fiber cable. The connection is, yeah, you can see the light will comes from the another end. This connection is like a nut bolt type connection. So you can see the output from the 1 meter optical fiber cable we can adjust. In example I am taking 100, but here I am taking 150. But the multiplier is always connected, always calculated with 10. So that's why the original value, which is only 15.0, don't consider 150. Okay, whatever the value, just divide it by 10, it's enough. So 15.0, because the trainer is already multiplied with 10, that's why. Okay, now connect this 5 meter optical fiber cable using this our coupler. So I am connecting the coupler here. Again it is a nut ball type, so fix the coupler. Now the second end of the coupler, fix the 5 meter optical fiber cable first end. Okay, and after that what happen, light will pass through the 1 meter coupler, and you can see, you can receive the light at the end of the 5 meter optical fiber cable. So this one is the whole setup, and you can see we got minus 23.1. now minus 23, which is less than minus 15, remember. So the setup is what, light will pass through this 1 meter, after that coupler, after that light will pass through this 5 meter cable, and our output is minus 23.1. so I am noting PO2 value, which is minus 23.1. okay, so I am calculating the loss for cable 2, it means 5 meter cable. So the formula is what? The formula is so simple, A minus B minus 0.5, and the 0.5 for the coupler, because coupler has its own loss. Okay, so calculate it. So I got 7.6. so this one is the loss for 5-meter cable. Now repeat the process but inward. First we are using the 5-meter optical fiber cable, and let's see. Yeah, you can see the light. Let's see how much the output we received when we are using the 5-meter optical fiber cable. So I received minus 16.3. okay, so I am noting PO2 value for 5-meter cable, it is minus 16.3. okay, and after that using the coupler I am connecting the second end point. Yeah, this one is the second end point. Now fix the coupler here and attach the 1-meter optical fiber cable, because I want to calculate the loss in 1-meter optical fiber cable. So I am connecting here, and whatever the end point of this 1-meter optical fiber cable, connect in the output node. So in this scenario, light will pass through this first 5-meter optical fiber cable. After that light will pass through the coupler, and after that light will pass through this 1-meter optical fiber cable, and we get the output minus 19.7. okay, so I am writing here minus 19.7. So how can calculate the loss in cable 1? Simple, B minus A minus 0.5. So I got 2.9, and here is a dash. So loss in 6-meter, it means what? Loss in 1-meter plus loss in 5-meter cable. So just add both the value. I got 10.5, so it is a loss in 6-meter, and after that I want to calculate loss per meter, so just divide it by 6 because it is 6-meter loss. So I got 1.75, and that is considered as a propagation loss or loss per meter. So our simple result is propagation loss is 1.75 dB per meter, but my value is little bit high. If you got 1 or less than 1, it is more correct, otherwise it is also correct, 1.75 dB per meter. Thank you.